In this video, we're going to explore how to name when you have multiple subgroups. So in this case, let us use this molecule. To start with, its longest chain, 1, 2, 3, 4 carbons long. So this is a bute. It's all single bonded carbons. It is a butane. But I have 2 carbons that are not part of the main group. They are separate from one another. They are not an ethyl because they are a single carbon in length. There's just 2 separate single carbon in length subgroups. How do I express these in the name? Well, they are 1 carbon long, so they are methyl. And there's a second one that is a methyl. I have 2 methyls. If I number the carbons of the main chain, they're going to be at position 2. That gives them the shortest number. If I tried numbering from the left, it would have been the 3 position that the methyls were on. So we want to number from the right to give them the lowest number. It's number 2. Well, there's 2 methyls. I can't just say the low position, I also have to tell you how many there are. If we had had this molecule, this also would have had 4 carbons long, and it would have had a methyl at the 2 position. So what's the difference in these names? Well, the one on the right is a 2-methylbutane, but the one on the left is a 2,2-dimethyl-butane. So we need to give the number for each subgroup's position. The fact there's 2 of them on the same carbon means we have to say it twice. There's a methyl. Where's the first one? It's on carbon 2. There's a second methyl. Where's that one? Oh, it's on carbon 2. You list the number twice, once for each subgroup there. Well, that's not enough on its own. We also have to tell you how many methyls are on the molecule. And so the di is telling us is that there are multiple methyls on this molecule. When you have a multiple of a subgroup, there are terms for different amounts. Mono for 1, di for 2, tri for 3, tetra for 4, penta for 5, hexa for 6, hepta for 7, octa for 8, nona for 9, and deca for 10, though we're rarely ever likely to see those. When you name a molecule that has multiple subgroups, you have to tell where each of them is, and for the methyls and the ethyls and any particular subgroup, you have to tell how many total of that group are on the molecule. Differentiating example for that, let's look at this molecule. Again, our longest carbon chain is going to be 4. We're going to have carbons that aren't part of the main chain at carbon 2 and at carbon 3. These are all 1 carbon long. These are methyls. In this case, though, I have a lot of them. So it is a butane for being a 4-carbon alkane. And this time there are methyls at the 2, the 2, the 3, and the 3. There are 4 total methyls, so I need to show 4 positions they are located at. And because there are 4 total, it is tetramethyl. This is a 2233-tetramethylbutane. We use a comma to separate the numbers between the different positions, and we use a dash always between the numbers and the name. So 2233 tetramethylbutane. It is possible to have more than one type of subgroup. So let's do a hexane. We'll put 2 methyls on it and an ethyl. And so if we follow along, 1, 2, 3, 4, 5, 6. This is 6 carbons long. There are methyls, and there is an ethyl. Which side do I start numbering from? Well, if I have options, I want to run into my subgroup as soon as possible. And so if I start from the right, I run into a subgroup at carbon 2. If I had started from the left, I wouldn't have hit a subgroup until carbon 3. I want to hit the first subgroup I can hit as soon as possible. Now, if we have other functional groups, we'll want to hit those functional groups first, but we'll address that when we reach it. Only thing on an alkane is the subgroups, so that first subgroup that you reach, you want that to be as low a number as possible. As a result, we will have methyls at the 2 position, an ethyl at the 4 position, and we have a hexane. So it is hex for being 6, ane for being an alkane. There's going to be 2,2-dimethyl, and there's going to be a 4-ethyl. Now, how do we put those together? Your subgroup lettering determines alphabetically. So ethyl comes before methyl. So we will take 4-ethyl and we will put it out front. We'll then take our 2,2-dimethyl. And I know there's a D, but the numbering specifier doesn't change the alphabetical order. It's the subgroup carbon chain alphabet that matters. And so methyl M comes after E. And so this molecule is a 4-ethyl 2,2-dimethyl hexane. It is 6 carbons long, so it is a hex. It's alkane, so it's ane. And it has 2 methyls at the 2 position, so 2,2-dimethyl. And it has a single ethyl at the 4 position, so 4-ethyl. So this is the basics of how you assemble multiple subgroups onto an alkane and how you'll do it on any other functional group. Let's give a practice. Go ahead and try to name these, and then come on back. All right, if you tried to name it, let's look at our options. So on our longest possible carbon chain, if you try all the different directions, you're going to find that it's 6 long. And even if we'd gone from the bottom and gone up to make 6, I would have had the same groups attached to the same positions. So this is 6 long. It has a methyl, and an ethyl that are not part of the main chain. So it's a hex, ane. It's going to have some dimethyl, and it's going to have an ethyl. But we need some numbers. What numbers are they going to get? Well, that leads us to a bit of a conundrum. If I start from the right, it is 1, 2, 3. If I start from the left, it is 1, 2, 3. Both directions run into something at the 3 position. If that's the case, well, one of those has multiple things. And so if I go from the right to the left, I would hit 3, 4, 4. If I start from the left and go to the right, it'll be 3, 3, 4. So given my choices, one of those routes ends up with lower numbers for the second group I run into. And so I would want to start from the left. That'll give me a 3 and then another 3 before I hit my fourth position. Or if I'd started from the right, it would have been 3 and then 2 4s. So if your first group you run into is the same from both directions, look then to the second group you run into. You want whichever path will give you the second group at the lowest number. And so we've got a 3, 4 dimethyl, and I have a 3 ethyl. And so if I want to string the name together, So I want to string the name together, 3-ethyl dash 3,4 dash dimethyl hexane. This tells us that I have a 6 carbon long chain, that the third carbon is an ethyl, that the third carbon is a methyl, and that the fourth carbon is a methyl. On the right over here, our longest chain, no matter what direction you go, is going to be 3 carbons, and it's going to have 2 methyls coming off of it. And so no matter how you do this, it is a 2 position for 2 methyls. So it is a 2,2 dimethyl. And it is a 3 carbon long, so it is a propane. And so it is 2,2 dimethyl propane. All right, that is the basics of naming alkanes with multiple subgroups. You identify the positions of those subgroups. You use the multiplier prefixes if necessary to describe that there are multiple of that subgroup. And you enter a number for each subgroup.